Hey guys, good afternoon. Unveiling the vulnerabilities, hacking cloud native apps, and discovering the silver lining. So I want to make this talk more interactive rather than just speaking because it has a lot more technical stuff. So if you have any questions, just raise your hand. Just give you context and some background about this particular talk. This is mainly when you do the penetration testing of any cloud application in a black box testing perspective. There are so many cloud components being used in the application, but all the automated scanner and normal traditional pen testing doesn't work here because the vulnerability related to cloud are different. So the whole context and objective would be from the black box perspective. It is not from the audit perspective where you have account in your cloud and you do the audit of cloud infrastructure. But this is from the hacker perspective when you do any application and doing a penetration testing, and all the cloud related vulnerabilities will be covered here. Most of the examples are from the AWS centric, but this can be applied to GCP and Azure as well. There are some scripts and some tools I will show you. So use these techniques in your company's applications doing pen testing, and use this recommendation as well. So just a small poll, like how many of you feel really that cloud security is really important? The traditional method doesn't work in cloud. How many of you really believes that? Okay, so let me show you like why this cloud is important. Myself, Amish Shah. I have 20 plus years of experience in application security, and being from the development background, I developed so many numerous tools in security and built an industry standard vulnerability scanner as well. I have passion about converting all the manual methodology to the automated way. So we try to use more and more tools which compensate your manual pen testing. I've done plenty of source code review and suggest innovative solutions to the partners, like how they can fix the vulnerability. We do lots of technology research, tools, and write blogs. And more interested is resolution in pen testing during challenges when you need to bypass some filters, bypass some mechanism, and how you can exploit the vulnerability. That is the more interest. The topics I would cover in this talk first start with the cloud application security. What is the current scenario and what are the real life cases right now happening due to cloud? Then when you get the applications, how do you fingerprint that application? How do you identify vulnerabilities? Then how do you exploit that? And then last would be mitigation and question answer. So this is the flow of the talk. Current scenario and real life cases. So if you look at the growth of the cloud, like in 2025, as per Gartner, 85% of the organization will embrace cloud first principle. So most of the applications will use some of the cloud components in applications. Sometimes your application won't use entire cloud, but maybe it use a Cognito, or maybe it use your bucket. Some part of your cloud resource would be part of your application. And the global cloud revenue would be, there was 474 billion in 2022, and 2023, it would be around 600 billion. So you understand like how the growth of the cloud applications. And if you look at the market of the cloud apps, the CAGR of 23.7%, it is increasing. The key players are Amazon is having 32%, Microsoft is having a 22%, Google would have 11%, and others, Alibaba, Cloud, Salesforce. So the growth and the market is increasing up. In 2028, it would be 7.0 billion with the market opportunity of cloud. And there's some surveys that like 99% company feel that their platform success is depend on their cloud security. So cloud security is much more important. And now if you look at the bugs, in 2022, there were 65,000 bugs were reported. It was related to cloud. There was a 21% rise in cloud flows compared to 2021. and 150% rise mainly due to cloud misconfiguration. So when you use the cloud component, which is cloud is really advantage in terms of go to market, everything is good because your cost is low, but at the same time security of your the cloud components is also very important. And 45% rise in API related issues. So out of the 65,000 bugs, that cloud misconfiguration and API related issues were most. Just take one example of Flickr. Flickr has account takeover, and it was a 9.8 severity. It was a complete account takeover because of their AWS Cognito user pool attribute were mutable. So attacker just change the email address to some user, and he can take the account of that user. Second example was booking.com. Booking.com has account takeover because of the incorrect OAuth handshake implementation. There were redirect URI which was not validated properly. There was open redirect, and with that mobile app, attacker can compromise any user's account. Optus faces $1 million ransomware because their cloud misconfiguration. Due to their cloud misconfiguration, attacker had access to 11 million customer records. He encrypted that and all the records. Because of that unauthenticated API, it gets access to customer database, and through privilege escalation, it can go into cloud. Twitter had a 5.4 million users stolen data, and it was due to the improper access control in the API. This recently there is a cryptojacking is also coming in picture, where Amber Squared and Squirtle is a two operation where attacker are not informing you that there is a cloud related bug in your application, but they take the control of cloud. They will use amplify, forget some of the features of your cloud and use your cloud for the crypto mining, because crypto mining is such a high-end process where it takes lots of out processes. So they will use your cloud for their crypto mining, and your bill will get like a rocket. You will get millions of billions of dollars in your bill. So they will use your cloud for the crypto jacking. So from the black box perspective, when you do any assessment of your application, there are three major cloud related issues. First is OAuth or SSO related issues, where if you use incognito or traditional OAuth to implementation. Second would be misconfiguration, where overly permissive IAM roles or insecure configuration of your cloud storage. Third would be API or lambda, where you can have event data injections or hidden or undocumented APIs or excessive data exposure. So these three are the major issue. When you do the black box testing of applications, you do find all these components, but normally the pen tester will look traditional vulnerability like SQL injection and all those things, but this cloud related stuff are getting hidden. So why are these vulnerabilities exist? Because if you look at the traditional architecture has, there are 3-layer architecture where you have controller, business logic, and repository. Normally files are getting stored in your database, and APIs are exposed through mobile or external services. But when you move to the cloud migration, you need to change your design. You need to change your design to your microservices-based architecture. You need to use the API or Lambda functions. You have to use a AWS Cognito or some OAuth true provider instead of normal form-based authentication. And you need to specify IAM roles for permissioning. So because of these changes, when you migrate your application to cloud, the cloud-related vulnerability has to be checked. So what would be the methodology? The methodology would be, the first and foremost is technology identification or fingerprinting. When your application is moving, this part is hidden. You can't see this from the outside that application is using cloud components. So first step is to identify technology, whether your application is using this, which kind of cloud technology being used. So you have to do fingerprinting through HTTP traffic, or you need to dump your mobile binary data and look at like whether any Cognito IDs are there or not. The second step would be the vulnerability detection. Once you identify these IDs, then try to look at that, is there any cloud related vulnerability exist or not. This can be through by AWS CLI or GCP CLI or Azure client, by which by running a certain command, you can identify that the vulnerabilities exist. Third step would be exploitation, where once you get the vulnerability, you need try to bypass restriction, try to do a misconfiguration parameters, get a higher privilege functionality, and get access to cloud. And fourth would be you need to inform your partner about the fixes, like how you can do a secure implementation of your Cognito or how you can secure a Lambda. So these are the four steps, and we will look at one by one. The first one would be technology identification fingerprinting. So when application uses your cloud components, there are certain signatures in the request and response in your HTTP traffic. So for example, if you want to look at AWS signatures, then URL subdomains would have Amazon AWS. If it is from client side, it is uploading some data, then the library would have AWS SDK, JS file will be loaded. The HTTP request and response header would have x-amz header. So from that you can figure out, okay, this application is using some resource of AWS. If application is using any Cognito or storage, then it would have Amazon Cognito JavaScript library being included, or certain IDs. If you use a Cognito, then it has identity pool ID and user pool ID. There are certain variables names. So those are being a part of your JavaScript, which is hidden, baked inside JavaScript. You can't see that on your web page. And if you're using a S3 bucket, then the URL would have bucket name like s3.amazon.com/bucket name or bucket name.s3.amazonaws.com. So these are the URLs would be there. If you're using a AWS cloud storage for GCP, then it's a storage.cloud.google.com/bucket name. So these are few signatures for GCP, Azure. If many times if you're using AWS Cognito, but by default identity pool were also there. So in that case, response will throw you access key, secret access, or session token as a part of response. So that may be available in your response. If application is using a lambda behind the scene, you can't see that lambda function in a front end, but in some error messages, some responses, if you see this lambda handles, if you see var/task directory or /tmp directory, or if application is using an API, then maybe /v1/v2 or /API, or domain name would have API. So these are the symptoms from which you can figure out that application is using these parameters. If application is using OAuth kind of thing, then response type, client ID, grant type. So these are a few keywords. From that you can figure out that application is using OAuth. But this seems like it's very difficult, like you cannot identify one by one. So there are some regex we define, like these are the regex you can use in your applications. But this is also cumbersome. So we made a one small burp plugin. So this is called a Cloud Assets Watcher. This is a plugin which is a part of a burp extension. And if you keep it, it continuously monitors your applications while browsing through. So while browsing your application, put a proxy, install this plugin. It will find your cloud assets, and it will show you as a part of the traffic itself with the color and which particular regex will match. So without doing any effort on searching, this will show you like this is the keys are available. And just to give you a little demo of this. So this name is Cloud Asset Watcher, and these are the regex as a part of the code. So this installs the extension. It's clear the history. And these are the regex, and this is continuously evolving. We are putting more and more regex inside them. So this is the URL of the application. For example, you are browsing this particular application. So now you are logging to the application. So this is sample vulnerable applications. Now, if you look at from the back end, it shows you all the parameters. So this identity pool ID is in particular JavaScript. So this JavaScript is a bake-in. It's a huge, if you look at it's like a 188.739 18 MB JavaScript. And here is the identity pool ID. And here is the keys, and AWS credentials are there. So from application perspective, you can't figure out that it is using cloud in the backend, but from traffic and from this, you can figure out, okay, this application is using cloud components. So this was the first phase where you identify, okay, this application has the cloud component being used. Now, how to detect the vulnerabilities? So to detect this, I will also include some of the technology discussion, like what this technology is. So AWS Cognito is an identity platform which is being used for the authentication and authorization purposes. And behind the scene, you can use any other IDP as well. You can use a Facebook, Google, any other IDP as well as a part of Cognito. There are two things. One is a user pool and another is an identity pool. User pool is mainly used for the app users. Identity pool is used for the AWS services. So for example, if you want to give some permission for one user to use any AWS services, then that user should be part of identity pool. So what are the vulnerabilities? So first one is, if application is user pool registration open or not. Ideally, if applications doesn't have any kind of registration feature, then user pool registration should be off. But so that is the first one. Second is user pool attributes should not be mutable. Mutable meaning that attributes of that particular user should not be able to change that. But by default, it is mutable. So user can modify this attribute. Third is, there is an email verified attributes. Email verified meaning when you register some user, there should be an email goes to that user will acknowledge that, and that email verified will make true. But many times this flag is false. So this is the third one. Then identity pool should be off for unauthenticated role. It should not be open. And does refresh token expire or not? So these are the 5 main vulnerabilities of this Cognito. We will look at the exploitation all in the exploitation section, but the first command, if you want to check whether registration is open or not, so there is called a sign up command of AWS Cognito. With this sign up command, I can check whether I can sign up as any new user or not. And this email verified, if it is enabled, then you won't be able to sign in unless and until you make it true. Once you sign up, there is a command called get user. See, this get user command will give you the attributes of that user, and this attribute give you very much more insight towards your user parameters. And if there are any custom parameter, for example, there is a company ID or there is an admin equal to false, there is a custom attribute. So by default, my admin is false. But if I can change the attribute, if I can change this admin false to true, I can be admin. So update user attribute is another parameter where you can check whether I can have permission to modify my attribute or not. Similarly, so you can, if you can change the email, if you can change the custom attribute, it is a vulnerability. Then fourth would be unauthorized role. So in an unauthorized role, there is a called identity pool ID. In the fingerprinting, we found that identity pool ID. So with that identity pool ID, you need to just get the ID, and that get credential for identity is a command by which you get the AWS credentials or with the unauthenticated role. So if you get that, you need to configure that, and with this get caller identity, you know that what permission I have, what is my account name, what is my user ID, everything I can get the details. And once attacker has this information, he can go inside with the privilege escalation, he can get the cloud access with the admin access. So this was for the Cognito. Now move to the second one, is called OAuth. So in a OAuth, there are two types of response type. One is a code response type, and other is a token type. Where in the code type, it normally get the code, send to the IDP, and collect the token. And in the token type, it passes your token as a part of fragment or your JavaScript through post message. There are various methods. So the attacker's goal would be to capture the access token. Once he has the access token, he can go inside. So how he can manipulate? So OAuth or SSO vulnerability would be, first is if any OpenID configuration is open or not. If you have OpenID configuration open, he can directly go that configuration, modify it. There are certain parameters of OAuth. The first one is redirect URI. So redirect URI is a parameter by which attacker can get the access token by just sending a request. So that redirect URI validation is missing, then we can abuse it. There is a similarly state parameters, and that state parameter is mainly to avoid CSRF. If state parameter is not being checked, then the CSRF could be possible. And there are some grant type interchange. Basically, this code and token, these are two types. So, and it is configurable. So what attacker can do, attacker modify from code to token. And if that implementation doesn't include this, it can reveal entire token to the attacker. And then there are sites in the leakages, because when this token will transfer from IDP to the client side, there are multiple ways he can transfer. One is a post message, referrer, open redirect. So all this transfer should be secure. If it is not secure, then this can be grabbed. Now third one would be the cloud storage. Everyone aware that people are using buckets for storage of file. Out of 10 applications, 8 applications would have buckets in the application, because most of the application use cloud storage for the file storage. Like if you are uploading any image or uploading any PDF data, it will go to the bucket. So in our experience, we found most of the applications it is open. So there are two ways you can use bucket. So as a pen tester, you need to identify whether how the application is using this bucket. Is this file is being uploaded from the front end, or it is from back end? If it is on front end side, then that application has to pass that AWS credential to the front end side. So he needs to look at these keys. Second is whether application is using any AWS signature is a part of file, because if the file is without signature, it can be authentication bypass, because anybody can open it. So that is the first check, whether application uses any AWS signature or not. Is there any hidden buckets? Many times applications there are 2 or 3 buckets into the applications. And the most important is application uses a common bucket for all users' data, because ideally all users' data should be separate. All users' data should not be in a one bucket. If it is in a one bucket, then there should be some mechanism by which, or directory base or some way, there should be some protection should be there. So those kind of checks should be applied. If it's using from backend, in a backend, you won't find any bucket name on the front side. So in that case, you need to look at whether when you upload some file, is there some activity on the backend? In that case, you can do some event injections as a part of bucket name, because when you are using a bucket from the backend side, the bucket name should be crucial, or file name should be crucial. And is there any credential leakage? Are there any events fired from the backend? So those should be checked. So if you look at the vulnerabilities, you need to first check that bucket URL is accessible without authentication. Are bucket URL accessible with AWS credentials? Because if it is a AWS credentials, then you need to look for the over permissive roles. What is the expiration time? Does the bucket contain any sensitive data like AWS credentials, server configurations, user details? Is there any signature generation logic? How the signature is being generated? Is it from a front end or back end side? And most important is event data injections. When it is using from backend, then how the event is getting fired, from which data this event is getting fired. So those parameters should be checked. So this was from the cloud storage perspective. Now IAM roles is very important in any cloud, because in a cloud the roles are dynamic. It is getting assigned. So roles as depend on requirement, it assigned to users. When you create any user in AWS, there are no roles assigned, and by default as per policy there is no access. Once you assign that role to user will get access. So AWS will have access by 3 methods. One is a console, one is AWS client, and one is API. So normally we feel that we can access AWS through console, but it is not the case. Attacker or pen tester normally use a AWS client to access all these things. So with the keys, he can access the AWS. So for example, here, if it is a policy of full access, he can access S3 bucket. If it is a read only, then only he can access bucket 2. He can't access bucket 1. So these are all the policy driven. So whenever you get the credentials, there are first 4 later. AKIA is called the long-term credentials, and ASIA is your short-term credential. So if you get a AKIA, then it is a long-term credential, meaning these credentials are persist in AWS. It won't change. It is very dangerous. And when you assign a role, it will give you ASIA credentials, which is short-term credentials. So, and there is command called get caller ID, which will tell you what the username, what the account name, what is the ARN name. So this information will give by this get caller ID command. So there are a few terminologies is important in AWS called ARN. By ARN, it identifies, for example, in this particular ARN example, you can say it's a AWS. The DynamoDB is a database. US East 1 is your region. Then it's an account number, and there's a table, and there's /product. So from ARN itself, we can figure out whether which resource this is talking about. Is it talking about database? Is it talking about user? It is talking about tables. So this is a unique ID of that particular resource. Then some of the other terminology would be users, groups. So when you have user, there are 2 types of user in AWS. One is the root user, and one is the IAM user. So root user would have very high privilege. He can do a payment or change account name. When you create any account, root user will automatically assign to that user. And IAM user has console, SSH key, certificates. So for that role, you create a policy and you attach that role to that IAM user. The role is something which is like a head. When user performs certain operations, it takes that role, do the operation, and once that role completes, it will have its old rules. So it is like a kind of user without a password, and the role would have 2 policy attached. One is a permission policy where specify that role can do this, and these things. And trust policy, like who can get this particular policy. So this is called trust policy. This 2 will be assigned to that role. And Why this knowledge is important? Because when you do the pen testing, you will definitely get some role, and to get a higher privilege role, to do a privilege escalation, you need to understand, you need to get that role, that which are the high privilege role, and then try to assume that role. So it is very important. So there are two types of policy. So the role would have policy attached to that role, and that policy would have action item which that particular role can do, and on which particular resource this policy will be applied. So there are identity based policy. Identity based policy assigned to users, groups, and roles. Resource based policy assigned to your S3 bucket, EC2, lambda, all the AWS resources. And in a resource based policy, you would have principal, because that resource is saying that only this particular principal can access this resource. That's why that principal should be least privilege. And there is called assume role, which I said before. Assume role is a by user can try to assume this role, and trust policy is a role by which principal which role has said that this particular user can only assume this particular role. So that is defined in your trust policy. For example, in this particular policy, there is a Bob is a user who has a role policy that it has assume role, and similarly admin role trust policy has the ARN of Bob. That means that Bob can assume admin role. So this is the example of assume role and trust policy. So when you look at the IAM role related vulnerabilities, you need to look at, is there any wide scope permissions, if there are any star policies assigned. If it is a star policy assigned, here if you say any action item instead of STS assume role, it's a star, then this user can do anything. This particular role can do anything. So the widely scope permission should be monitored. Resource policy should have clear-cut indication of principles. It should not have like a large group of principles. So it can say only this user can access, or only this group of user can access this resource, not all the resource or the users. So there are multiple techniques of privilege escalation. One is user level permission through IAM commands, or attacker can add this permission to user or group. Attacker can assume high privilege role. There is called update assume role policy. Sometimes this update assume role policy is also open. So attacker can directly append or edit this update assume role and get the role. And fourth and fifth one is IAM pass role. IAM pass role is a permission where user can pass the permission to the user. So these are the 5 main parameters by which he can do privilege escalations. So this was mainly from the IAM role perspective. Now, from the AWS API or Lambda perspective, if you look at, there are 3 types by which API can be called. One is by default web API or REST API, where from front end directly call the backend through API. Second would be API gateway. So for example, if you're using a Lambda function, then Lambda function would be behind the scene, and API gateway would be there. So application will talk to API gateway, and API gateway will talk to Lambda function. This is the second way. And third one would be, there are Lambda function URL. So when you create a Lambda function, you can directly create a Lambda function URL, and that can be directly called from the outside. So these are the 3 ways any application can call the backend function. So to make it, during a pen testing, you need to make an API inventory and data modeling, like how the entire applications is calling API. What are the different sets of API being used in the application? And from that, you can target different attacks. So if you look at the API vulnerabilities, there are undocumented or hidden APIs being used in your JavaScript or code dump. Second is a deprecated version. If you see V1, V2, V3 kind of things, then it's a application using a 2 or 3 set of APIs. Many times applications API throws many data, unnecessary data. For example, they're throwing that admin false and all these things. So from this leaked sensitive data, attacker can use and abuse it. Fourth would be object property assignment, where with this linked data, if I can pass during a assignment those parameter, this can be assigned to the end entities. And fifth one would be BOLA and BFLA, basically unauthorized access to the endpoint. It's a broken object level access, broken function level access, authorization excuse. And in terms of lambda, you can say overly permissive resource policy. So many times lambda functions policy are such that anybody can create new lambda function, or that lambda function can be invoked. So those permissions without being assigned. Second would be there are a create or edit or invoke permission is available. So attacker can create new lambda functions, and in that lambda function he can write that I can have access to this resource, and he can do that. Third would be event data. Basically, when the lambda function is getting called, when you pass a data, if that data has any access to outside, that event data injection can be possible. Many times lambda function using some unsafe function like OS command, or they're using some pickle functions which has very highly sensitive. So if lambda function using any unsafe code, then it can be vulnerable. And lambda configuration like a rate limit, DOS protections, logging and monitoring should be enabled. If it is off, then also it can be abused. So now part of the exploitation. So in exploitation, so let's look at both the cases, Flickr and booking.com. We'll look at one by one. So this is exploitation of redirect URI. So if you look at this diagram, attacker crafted one URL with the redirect URI of the attacker page and send it to the victim. If victim clicks on that particular link, it will redirect back to the attacker's page, and it leaks the token of that particular login. So redirect URI should be properly validated on the server end. If it is not validated, so that was one of the case on booking.com. In the booking.com, the domain was proper, but the URL was not getting validated. We will look at in a fourth step. The second exploitation is a CSRF on a state parameter. So what is the importance of state parameter? State parameter is basically when you do a OAuth integration, in a first step, it passes to victim. Victim enter the credentials and returning back. So when sending a first request and returning back to the third request, there should be some relation, and that relation being maintained by state parameter. So if state parameter is not validated, attacker will create his own OAuth token, send it to victim. And if victim clicks on that, then victim will pay attackers or bill or purchase anything. So with the state parameter, the CSRF could be possible. Third would be grant type issue. Like grant type is I said like a code and token. There are two types. So if application is implemented a code type, and if I change to token type, and if the application is not taken care about that, then it can be leaked access token. And that was the second step attacker use in a booking.com, where it passes a code comma token. So it passes two things instead of code, and applications throws access token instead of code. So here is the entire scenario. The first, attacker bypasses redirect URI, but in the bypass, attacker found that there is a domain validation, but the path behind after the domain can be changed. So he found open redirect vulnerability in the booking.com and then used that in this particular attack. Then also he won't be able to get the access token. So he changed the grant type, and grant type changed to code comma token. So he get the code, but then that login code didn't work. Why? Because Facebook was validating that this redirect URI was different. Then he struggled few things, and then he looked at the mobile app. Mobile app of booking.com uses different API. So as I said, like you shouldn't make your API different for mobile or for web app. You should use a common API. This API was different, where it was passing a redirect result URI as a part of parameter. So the step was simple. It's intercept, get the access token, then in the mobile app he passes the result URI and change the code with the victim code, and game over. So there are 3 or 4 attacks combined, and then it get the code of that, and access account takeover is possible on booking.com. So this was with the OAuth. Now AWS Cognito. If you look at this application doesn't have any registration, right? But still applications throws identity pool ID, user pool ID as a part of JavaScript. So in a fingerprinting, we found that there is a identity pool ID here. So as a first step, as an attacker, we try to sign up with the one user. So sign up with the user one@blueinfo.net, and it says successful. And if I look at the confirm sign up with the some code, it says it is enabled. So there was no registration, but still behind the scene registration was open. So attacker could register one user. Then he looked at the login process. In the normal login process, it give you access token, identity token, and refresh token. So this is the step. And once he get the token, he look at the parameters of this user. So with the get user command, these were the parameters. Parameter was email verified, phone number, and email. Now this parameter should not be mutable. So the next step would be try to update this parameter. He could change the parameter of email from user 1 to user 2. So basically I can switch from user 2 to user 1. So I can change my email address. Now if application is taking a decision based on this parameter, it can be a complete authorized by account takeover, because if I know your email address, I could modify and I can get access to your account. And this was the case with the Flickr. So this I modified to user 1. Now in a Flickr has the same issue. Flickr was taking a decision based on the email address. So this was the Flickr was using Amazon Cognito as a authentication and authorization purpose. So here is the access token. Now in this step, it get the all the attributes and then try to change the birth date. And the birth date attribute was possible. So he said, okay, now birth date is possible. He tried to change the email address. So he changed the email address to somebody else's email address. Then during the login process, he gave his username and password. And then this was the attacker's victim's email address. And with this email address, he could get login to the victim's account with just by modifying the email address. Ideally, applications should take the decision based on a sub, not on the email address. So that was the problem. So that was user pool. Now in an identity pool, if there is an identity pool there, because user pool you normally use for the application hacking. But for example, if I want to go into cloud, then I have to mess with the identity pool. So identity pool, it gives you identity ID with the get ID command. And then with the get credentials, without any authentications, it is giving you all the AWS credentials. So once you get the credentials, what you can do, you just configure on your machine, and then you perform following steps. So once you get the credentials, these are the exploitation method for the privilege escalations. First, you need to list the policy, which is the policies available in your AWS. Then list of users, list of roles. Once you get the list of roles, try to identify which is highly permissive admin account, because to get the account you need to be a admin. So you get the policy of that particular high permissive roles, and then for example, here you are looking at that this particular role has a permission, like EC2 can access this particular user. So EC2 can assume this role. So what attacker will do? Attacker will create a EC2 instance, assume high privilege role, create an instance profile and attach to that particular new instance. And once he attach that with this metadata, he can get the credentials of admin accounts. So this was the basically yeah. And this is for the unauthorized S3 buckets. So for example, if you are getting S3 buckets, there is one scripts, which script you can utilize to identify. Let me go through it. So this is a script. You just give the URL of your bucket. It will identify whether this bucket is public or not, what are the data inside the buckets. So this is unauthenticated scan where you are not passing any credentials. You just give the URL of the bucket. So this will give you that. And this is for the GCP. These all the commands are for if you want to access GCP, and these are the permission for the GCP as well. Like you can manually check the permission of that. So now this is for the API lambda where you can have improper asset management. So here is a V1 where it's from V1 you can find out there are multiple versions. So if you run a debug command, it will throw you admin accounts, email address. So this is a leak of sensitive data. Now you can use this in your registration. So this is a mass assignment where you register with the admin true and you will be admin, because here you are passing this admin parameter as an input. And if you look at, you will get the details like it says admin true. And this is a book title which is not accessible without authentication. You log in with that. And then if you pass a book title 16, it is my privilege. But now if I pass this book title 22, it will give you the admin account books. So this is the unauthorized access to other books. And this is an example of lambda, which is a policy which is highly, it says invoke function and create, both are accessible. So this is overly permissive example. And this is an example of event data injection. If you look at here, there's an OS.system is being used in the code itself. So if you are passing this particular attack, it will give you the environment variable of the AWS. So there are some mitigations, as already explained the mitigations, that you shouldn't have this registration open. And interestingly, this one is very interesting, where just look at that action, principle or resource should not have wide scope. If you just look at this, you can protect your cloud. And for API lambda, the important part is there should not be any hidden or undocumented APIs, because nowadays most of the case where there are documented APIs are few, but if you look at the traffic, you will see lots of APIs that are not documented. So you should have clear-cut guidelines for that, and there should not be special API for mobile. And user ID should not be passed as a request, because applications should detect user ID from the session. It should not be part as a user ID as a part of the request. And my conclusion would be traditional scanning won't work for the cloud. You should make your inventory of the cloud resources. Scrutinize IAM policy for users, roles, and resources. You configure alerts for billing, because if somebody uses your cloud from billing perspective, you can figure out that there is something going wrong. You should monitor act on your cloud logs, CloudTrails, or X-rays. And there are some tools and some blogs on blog.bluehair.com. There are escalation techniques and some cloud auditing tools which you can use on your cloud infrastructure. And that's it. Thank you.